Alright, this is the second video on the improper integrals, and we're going to look at, I think, two examples here. The first one we're going to look at is the integral from 1.1 to infinity of e to the negative 1.4x dx. So this means the limit as b goes to infinity of the integral from 1.1 to b of e to the negative 1.4x dx, which is equal to the limit as b goes to infinity of e to the negative 1.4x divided by negative 1.4, evaluated from 1.1 to b. This is equal to the limit as b goes to infinity. We'll factor out the negative 1 over 1.4, and then that's going to be 1 over e to the negative 1.4x, and we'll go ahead and put in the b, so it's going to be 1 over e to the 1.4 times b minus 1 over e to the 1.4 times 1.1. So what's going to happen is this is going to go to 0 because the denominator is going to get huge, and so our limit is going to be negative 1 over 1.4 times 0 minus 1 over e to the 1.4 times 1.1. So our limit is 1 over 1.4 e to the 1.4 times 1.1. And this is a finite value, and so we would say that this integral converges, and the area under the curve from 1.1 to infinity, if we keep going and keep going forever, adding it up, it's going to be approximately 0.01531. Okay, so nice convergent integral there. Okay, we're going to look at one more in this video here, so this will be probably a short video. So we're going to look at the integral from negative infinity to 3 of 1 over x squared plus 1 dx. Okay, this is going to be the limit as b goes to minus infinity. Now I think in the definition we used a. It doesn't really matter which letter you use here. So we're going to say b goes to negative infinity of the integral from b to 3 of 1 over x squared plus 1 dx. It's going to be the limit as b goes to negative infinity of the arctangent of x evaluated from b to 3. From b to 3. So that's going to be the limit. B goes to negative infinity of the arctan of 3 minus the arctan of b. Okay, and so if you remember roughly what the arctangent looked like, is it had a horizontal asymptote at pi over 2 and a horizontal asymptote at negative pi over 2. The arctan of 1 is pi over 4. Okay, the arctan of negative 1 is negative pi over 4. Arctan of 0 is 0, and so it's going to look something like this. So you can see by the end behavior, as we go to negative infinity, the arctangent is approaching the lower horizontal asymptote of negative pi over 2. So this is equal to the arctangent of 3 minus, and the arctangent of, not negative infinity, but what happens when we approach infinity of the arctangent is going to negative pi over 2. And so that is going to be approximately 2.8198, and that's the area under the curve from negative infinity to 3. If we keep adding that up, keep going off to minus infinity, it's going to get closer and closer to 2.8198. Okay, so again, this was a shorter video. Stay tuned for the last video where we'll look at integrals that have an infinite discontinuity either at an endpoint. So we're going to be looking at intervals of finite length. So you might have infinite discontinuity at the left endpoint or the right endpoint, or you might have one in the middle. And so the technique is going to be fairly similar, but it'll be good to see a couple examples. So stay tuned for the next video.